So hello guys, this is the second part of our video of quantum mechanics. Today we will study about Heisenberg's uncertainty principle. So before going to this topic, let's discuss what we have studied in the previous lecture. So the previous lecture we were discussing about the relationship between phase velocity and group velocity. We have studied that the phase velocity is equals to omega upon k and the group velocity is equals to del omega upon del k. So the relationship between phase velocity, we have derived this expression like this. We have solved the whole derivation. We have got the result Vp is equals to, that is phase velocity is equals to omega upon k, and the group velocity is equals to d omega upon dk. And then we have used both the equations and solved through a single equation and derived the formula that Vg is equals to Vp minus lambda dVp upon d lambda. Then we have put that in dispersion and non-dispersion solutions. So for non-dispersion solution, dVp is equals to 0. Therefore, group velocity is equals to particle velocity and phase velocity. And for dispersion medium, we have taken positive and negative both the cases. For negative cases, Vg is greater, and for positive, Vp is greater. We have studied this in the last class. In the previous class, and I will give you the link in the description. You can watch it. Today we will study about the Heisenberg uncertainty principle. So Heisenberg is the name of a scientist who have done this experiment. So it states that it is impossible to determine the exact position of momentum of a particle, moving particle, simultaneously. So here the word simultaneously is quite important. Okay, why? So basically, what does it means? That it means that if you if a particle we very well know that a particle or electron or any particle has a dual nature. It has a particle nature as well as it is a wave nature. So uh, you can say that it is the first step towards the particle, the wave nature of the particle. Before that, uh, the people, the scientists believes that any particle is up, any particle is in a say electrons, any light particle is in a form of packets or particle form. Then light particle is also known as photons. So this is the verge of that particle conceptual theory. So what does it means? Okay, so it says that delta x dot delta p is greater than or equals to h upon 4 pi. Here delta x is change in position, delta p is change in momentum, and greater than or equals to h, where h is Planck's constant. Okay, there was a scientist called Max Planck. His name's constant is Planck's constant upon 4 pi. 4 pi we act as a constant. So we have to derive these two equations of Heisenberg, that is delta x dot delta p, or the second one is delta E dot delta t is greater than or equals to h upon 4 pi. So the first is position and momentum. So first of all, let us consider we have two waves. Okay, we have two waves. So if we talk about waves, we can write the equation of wave. That is the basic equation of wave y is equals to a sine omega t. That is a sine omega t. You can say it like that. A sine omega t is a basic equation for each and every wave. But if we are discussing about a special type of wave, we have taken two waves. Okay, we have taken two waves. The first one is we named as y1, and the second one we named as y2. We have chosen their angular frequency. The y1's angular frequency is omega 1 and y2's is omega 2 respectively, and same as in the case of k1 and k2. So according to our first equation, we can make our first equation that y1 is equals to a sine omega 1 t minus kx k1x. Okay, so here k1x, it is very important to know why it is there, why there is minus. Okay, uh, we can determine it with the help of a diagram, that if we are drawing a wave, here k1x determines the time that we are subtracting some amount of time with omega 1 t. That is a different thing. Here we have two waves taken and the two waves equation are given. Is given. Okay. Now the resultant wave, the resultant displacement of wave, that is y1 is the one displacement for first wave, y2 is the displacement for second wave. The resultant displacement of wave y is equals to y1 plus y2. Here we can add these both equations 1 and 2. On adding, we get y is equals to a sine this. Now we can apply the formula of sine a plus sine b is equals to. So basically, sine a plus sine b is equals to 2 sine a plus b by 2 into cos a minus b by 2. And we can write it like this. And after solving it, basically we take a negative in this bracket and open it. This equation, final equation. Now we assume that omega 1 plus omega 2 by 2 is equals to omega. We assume this thing, omega 1 plus omega 2 by 2 is equals to omega. K1 plus K2 upon 2 is approximately equals to K. Because if we talk about omega, angular frequency, then it's a very small quantity. So we can assume this as the angular frequency of a single wave. Rather than supposed to tell it as a two-wave system, we can suppose it as a single wave. And like this one only, that is omega 1 minus omega 2, we consider as delta omega, that is change in omega, change in angular frequency. And k1 minus k2 is equals to delta k, that is change in angular wave number. And further, after assuming these quantities, we can put it in the equation. We get this equation. Now, from here, we are supposed to get, this is a two-wave system. This is a wave, the upper line is a wave, okay, and this is another wave. Okay. And here, where the two waves meet, this point is known as nodes. So what are nodes? Nodes are the point where the waves and the particles, here this is small lines denotes the motion of a particle, of the particle nature of that particle, the matter. Okay, so the place where the particle and the wave met is known as nodes. In this place, and this is group velocity. Group velocity is equal to particle velocity. What does it mean? It means that the velocity of the wave is equals to the velocity of the particle. If we suppose that this distance is x1 and the another node which is formed is x2, then we can clearly see that in the next equation. Okay, so we say that this is the direction of the wave. Here it is the direction of the wave. Okay, and this is the direction of a particle. This is the direction of a particle. So the wave moves like this, wave, and particle moves like this, particle. This is the velocity of the particle, this is the velocity of the wave. Both makes an angle of 90 degree. You can see that. Both makes an angle of 90 degree at nodes. Okay, that's why cos, that is this cos delta omega by 2 minus delta kx by 2 is equals to 0. What does this 0 symbolize? 0 symbolize that both, because cos 90 is equals to 0. We are not cos 90 is equals to 0. Therefore, cos this is equals to 0. So if cos is equals to 0, then the inside quantity, the angle between them must be equals to this plus minus pi by 2, plus minus 3 pi by 2, and plus minus pi by 2, 7 pi by 2, like this quantities. Okay. So let's uncertainty position. Let us consider uncertainty position as x1, x2. So we have considered it, and we have make this x delta omega upon into t minus delta k upon x into x upon 2 is equals to lambda. This is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. Now for first equation, for further solve it, okay, we take first lambda by 2 up to lambda by 2, and second equation we take up to 3 pi by 2. This is the first equation, I have written this. Second equation, I have written this. This is nothing but the first term of this. This is the first term, and this is just a second term. You can write in place of pi by 2 in this 2n plus 1 pi by 2 in this in the place of pi by 2 and 3 pi by 2. You can write easily 3 pi by 2. It's not, it's 3 pi by 2. You will get the same result. Okay, so we have subtracted it 3 minus 4 this equation, and we get this. After solving, after subtracting basic mathematics, we get uh, delta k is equals to this. Delta k is equals to delta k into delta x is equals to 2 pi. Here we can conclude that the product of uncertainty of position and momentum equals to constant. No, it is not momentum, I know. But you can further solve it that delta x is equals to 2 pi upon delta k. Delta x is equals to, in place of k we can write k is equals to omega upon lambda. Yes, omega upon lambda, and lambda is equals to h upon p. So here h upon p, this is h. So the p goes up, and this equation form 2 pi p upon h, and h goes up, that 2 pi h by 2 pi del p. So 2 pi to 2 pi cancel, and after cross multiplication, delta x or delta p is equals to h. Here h is the Planck's constant, which is also constant. Here we can conclude that the product of uncertainty position and uncertain momentum is equals to a constant. It is Planck's constant. The value of Planck's constant is 6.632 into 10 to the power minus 34 joule seconds. Okay, so this is the equation. Delta x or delta p is equals to h. Delta x or delta p is greater than equals to h upon 4 pi. 4 pi is a constant which is added in h, so that it is less than equals to the delta x or delta p value. H bar we have taken some minimum constant. H bar is equals to h upon 2 pi, which is used for the easy calculation and the ease of the calculation of the questions. Now let's move to the second equation that we have studied, that delta E or delta T is greater than equals to h upon 4 pi. So the second equation is energy time relation. So the same process we have considered as a particle of mass m and the velocity v moving with the x direction, and kinetic energy of particle is 1 upon 2 mv square. Okay, so if E is equals to 1 upon 2 mv square, why not multiply both the sides by numerator and denominator by m? We get 1 upon 2 m1 square v2 m square v square upon m. So p square is equals to m square v square. So E is equals to p square upon 2m. Why not differentiating it with respect to momentum? That means delta E dot delta divided by delta p is equals to 2p upon, after differentiating p square, the differentiation of x square is 2x. So the differentiation of p square is 2p. 2 and 2 cancel. So delta E upon delta p is equals to v. What is v? V is the velocity. What is velocity? Velocity is change in momentum, a change in displacement with respect to time. So delta E upon delta p is equals to delta x dot delta t. After cross multiplication, delta E dot delta x upon p, x upon p is equals to h. So delta E dot delta h is equals to delta E dot delta t is equals to h. What does it symbolize? It symbolizes the product of uncertainty of energy and time equals to the constant. Here it is the equation. The Heisenberg uncertainty principle is derived. So the reason why I have explained it so intensively, so quickly, that I have to show you a conspiracy theory. Okay, that Einstein has shown interest in it. That we can Heisenberg uncertainty theory is basically a myth, you can say. According to Einstein, if you follow Einstein, if you have watched his movie or you read his books, he mentioned that Heisenberg uncertainty equation is actually a false or a reason to not to it's basically an excuse, okay, to many of the theories. So how can we say that? If we take two objects, if we take two objects, okay, attached together, together in the sense that they are mathematically attached. Let's suppose it is x, so this is y. That means x depends on y, which are mathematically inclined. You can say in the terms of maths. And if you throw them apart in opposite direction, you cannot, according to Heisenberg's uncertainty principle, you cannot define the momentum and the position of any particle, moving particle, in simultaneously. Okay, but you can define the momentum of this particle, didn't you? Momentum, but and you can define the position of this particle. This is we can say position and momentum. You can determine the momentum of this particle. You can determine the position of this particle, because you are not defining the momentum and position of same particle. You can determine only one quantity. So either you take position of this particle and momentum of this particle, and you know very well that they are mathematically inclined. That means they are mathematically inclined. It means that you can also find their position through each other, and through mathematics you can say that you have, if it is a mass of m, it is a mass of m, then you can say that of 2m mass, you have determined the position and momentum of a single particle, that is of mass 2m, which is mathematically you can derive that. So here the Heisenberg uncertainty theory is be certain through certainty. Okay, this is the thought. This is thought experiment of Albert Einstein. You can further read about. You can further, if you have interest, you can comment it out. I will explain a full video to it. Make a full video. Okay, I can make a full video. Let's move further. The applications of Heisenberg uncertainty principle. The first application is determination of position of a particle by microscope. So here we have considered a X-ray moving in the X direction. Okay, here's it is a X-ray. This is a X-ray moving in X direction, which is the X-axis. Okay, there is certainty in position of electron. This is a microscope. We are watching X-ray. In X-ray, there is a moving of electrons. Okay, so if we see at any point in X-ray, that is delta, there must be delta X. What is delta X? Delta X is the uncertainty in position of electrons. Okay, delta X. And by diffraction rule, this is the diffraction rule. What is diffraction rule? Um, Diffraction rule states that if 2d sine theta is the distance is equals to n pi, where n is the number of order and n lambda, n is the number of order, either it is the first element or first order. Okay, and d is the distance between the diffraction between the two slates, between the two parts. Okay, so one part is a two-part microscope, and sine theta, where theta is the semi-vertical angle. It is it is this is, and this angle is known as theta, semi-vertical angle. This angle is theta. This angle is also theta. Both angle comprises to become 2 theta, which is a semi-vertical angle. So on applying this concept to this X-ray rule, this position of microscope rule, we can say that 2 into delta, here is d, here is delta x. Sin theta is equal to n lambda, where the number of order is equal to 1. So delta x is equal to lambda by 2 sin theta, where theta is the semi-vertical angle and lambda is the wavelength. And if we talk about the component of momentum in this X-ray, we can easily say that the first component is this. This is p sine theta, positive theta, and this is p sine minus theta, which is negative theta. We have made a assumption that this side is this clockwise side is positive and anti-clockwise side is negative. Okay, so After finding uncertainty in momentum, we have two components of p is equals to p sine theta and p sine minus theta. After taking uncertainty of momentum, delta p is equals to p sine theta minus p sine theta, which is equals to delta p is equals to p sine theta. So according to Heisenberg uncertainty principle, we can multiply both the equations, and on multiplication, delta x or delta p is equals to lambda upon 2 sine theta into 2p sine theta cancel, 2 cancel. So delta x dot delta p is equals to lambda p, and p is h upon p. What is p? We can say lambda as h upon p. So p and p got cancelled, and is equals to lambda h. H is a constant, and this is a again delta x or delta p. So Heisenberg uncertainty principle is derived from this application, which is application determination of position of particle by microscope. We have determined the position. Now the second application is diffraction of electron beam through single slit. The concept remains the same. We have a single slit. The diffraction between the distance of this single slit, the uncertainty in position in the electron is delta y. Delta y is uncertainty of the position of the electron. After the uncertainty of the position, either the particle will move in this direction, making an angle theta 2 theta with positive theta and negative theta, which means 0. So the maximum intensity is at the center. Let us consider single slit AB with which we can read this. So according to diffraction principle or diffraction rule of a single slit, delta y sin theta is equal to n lambda. It is the formula. That is E sin theta is equal to n lambda. E sin theta is equal to n lambda. Similarly, in place of E, we can write delta y sin theta is equal to n lambda for n is equal to 1. It is first order, first wave. So delta y is equal to lambda upon sin theta. Again, taking two components p sin theta and p sin minus theta, we are taking this p sin theta and this is p sin minus theta, and minus it and subtract it. So delta p is equal to p sin theta minus p sin minus theta. Sin minus theta is equal to minus sin theta. So delta p is equal to 2p sin theta. And after multiplying it, again got delta y dot delta p is equals to 2h. Delta y is uncertainty in position. We have considered this earlier. So again we write it. If you have any doubt or any queries related to these steps, you can comment it in the comment section. The third and the last application of Heisenberg uncertainty principle, it is the electron resides inside a nucleus. Okay, it is quite interesting, but it derives that an electron is always inside a nucleus. Okay, how can we say that electron is always inside a nucleus? So we very well know that the radius of nucleus is 10 to the power minus 14 meter or 1 Fermi. Okay, so how is the diameter? How to find the diameter? So diameter is basically 2 into radius. So diameter d is equal to 2 into 10 to the power minus 14 meters. So if we have a particle inside the nucleus, the particle must go. If we consider that it is inside the nucleus, the particle must go through this area only. It means can go up to this diameter only. Diameter of this one. Let's suppose this is the nucleus. It can go with through the diameter only. The maximum distance it travels is through the diameter only. Okay. Uh, so we can say that the uncertainty in the position delta x is equals to that itself the diameter of that nucleus. Okay, so delta x is equals to 20 to the power minus 14 meters. So delta x is equals to delta x or delta p is equals to h upon 2 pi. Here 2 pi we can call it 4 pi, but we can take it 2 pi also for the betterment of the calculations and not really mesmerizing it. Okay, so delta p is equals to h upon 2 pi delta x. So if we put the formula, the value, then delta h is equals to 6.6 into 10 to the power minus 34 upon 2 into 3.14 into 2 into 10 to the power minus 4. That is 14. It is 14. Okay, sorry. So it gives 0.5 to 10 to the power minus 20. This is delta p, change in momentum. Okay, so this is again equation of energy, that energy of kinetic energy of an electron moving with a velocity with a speed, with velocity of speed. It means a electron which is moving with a velocity of speed, moving is at a light speed has a basically kinetic energy of this, what is E is equals to under root p square. under root p square into c square plus m naught square c to the power 4. Here, if any particle, any matter, any electron, any neutron, any proton is moving with the speed of light, the mass of that particle remains zero. So the mass remains zero. So E is equals to under root p square c square. E is equals to pc. We have find the value of we have got the value of p, and we also know the value of c, that is 3 into 10 to the power 8. We got it. The energy is in joule. We can convert it by dividing 1.6 into 10 to the power minus 19. It got in electron volt, the unit change. Again, it is a very large quantity. We can easily make it with mega electron volt. One mega electron volt is equal to 10 raised to the power 6 electron volt. 10 raised to the power 6 electron volt. So the overall after overall calculation, we get E is equals to 928 mega electron volt. Uh, this is the so here the end comes. We have studied a whole Heisenberg uncertainty principle. We have discussed each and every step of its derivation. We have also discussed how we can disprove Heisenberg uncertainty principle with certainty. That two particle theory of Einstein. How why Einstein hate Heisenberg, because Heisenberg theory is just an excuse. Uh, so I think uh, it's good for this day. In the next lecture, we will study about the momentum operator functions, and the most important thing, that is we try to complete that Schrodinger wave equation, time dependent and time independent. You will love this equation. It's quite overpowered, we can say that. And then we'll study in the next lecture, the three particle system in a box, three particle system in a box, free particle system in a box. Okay, we also derive the equation of it, and then we'll got about some normalization condition, and then the chapter is over. Quantum mechanics is done, will be done. So thank you for watching. If you if you are till the end, please like, subscribe, and share to your viewers. Your uh, and keep supporting. Okay, thank you.